All right. Um, so the first part of this is a table that translates all the math operations we know, adding, subtracting, multiplying, what have you, into from key phrases. And here's an example using that key phrase and how we would translate that into a mathematical expression. So we have certain ones that are kind of important that we use a lot and they're highlighted. So, like the word sum of means to add, and it's there. I want you to highlight or underline less than under subtraction. Okay, because that's kind of the exception. The word less than, like for example, four less than a number, it doesn't mean four minus, it means minus four or negative four. So four less than a number translates to x minus four. That's kind of an exception to what we normally see. But these are all the keywords. Like for example, product is an important one. The product of 14 and a number would be 14 times x or just 14x. Quotient for dividing. The quotient of a number and 7 would be x divided by 7 or 7 over x over 7 rather. Okay? So we're going to be referring to these over and over. Let's start with number 1. Okay? So let's see here. Our first phrase is 11 more than twice a number is negative 19. 11 more than twice a number is negative 19. So we have 11 more than. I'm going to highlight that. That's a phrase that tells me what to do. Followed by twice a number. That tells me to do another mathematical operation. And then we have is negative 19. All right. So let's see if we can't break these down into key phrases. 11 more than, what does that tell me to do? 11 plus. 11 plus. Then we have twice a number. 2x, 2n. A number is going to be our key that we have a variable in its place. So I'm going to use 2 times n. And then is negative 19 equals negative 19. Okay? So let's go ahead and put that all together. So we can say, for example, 11 plus, and then 2.n, we could just say 2n, right? Whenever we're multiplying a number times a variable, we don't need anything. And then equals negative 19. So that's one way to write this. Or we can use the commutative property. Remember, when you're adding two things, you can reverse them. This is a little more common to write. 2n plus 11 equals negative 19. Okay? So on the homework or on the quiz tomorrow, you would also have to solve this. Okay? Any questions? Okay. Let's move right along. What is the word product? Flip your paper over and let's see what the word product means. Because our first phrase is the product of a number and 6. The product of a number and 6. So whenever we use the word product in math, what are we doing? Yeah, if we look here under multiplication, product tells us what to do. So that's telling us to multiply. And the things we're going to multiply are a number and 6. So this would be n times 6. the product of a number and 6. Then we have increase by 10. That's telling us to add 10. And finally, is the same as 64. That's another way of saying equals 64. So these are the different parts that we're going to put together. Okay, let's start with n times 6. Normally we don't write it that way, right? How do we normally write it? 6n. And then increased plus 10 equals 64. So as you can see there, most of them are just going to be two-step equations that hopefully are easy for you to solve. We just got to break it down and know what the different words mean. All right, let's go to the next one. 8 less than 3 times a number is negative 23. It's a lot to take all at once, so let's break it down. What's our first phrase? 8 less than. And then we have 3 times a number. So I'm going to highlight that. And finally, is negative 23. Okay. That's not too bad. Okay. Now, let's see what these things mean. 8 less than. What does that tell me to do? Subtract. What am I subtracting? Yeah, it's telling us to minus or negative 8. Let's go to the one I asked you to highlight, less than. 4 less than a number meant minus 4, right? Even though 4 came before less than, it means take away 4. So over here, this means minus 8 or negative 8. 3 times the number, that would be 3 times n. And then is negative 23 equals negative 23. Okay, so we have that. Let's write it down. Let's see what we have. 8 less than, well, that's either negative or minus 8. Then we have 3n. Is this 3n by itself there? Is it positive or negative? Positive. So we would write plus 3n. And then is negative 23. So that's one way to write this. Next, we would put or. Again, it's adding, so I can flip these. I could put 3n in front. And then since this is negative, I would put minus 8 equals negative 23. And make sure you write these down. And if you don't have a highlighter or two, you can just underline the parts I'm highlighting. Okay. Ready for number 4. We talked about quotient already. What does quotient tell us to do? Divide, yeah. So quotient here means to divide. Okay, so let's get our phrases. The quotient, that should be of. I apologize. Sometimes I type faster than I think. The quotient of a number and 12. That's our first phrase. The quotient of a number and 12. What is that telling us to do? Well, I know quotient is divide. What am I dividing? 12 with what? Yeah, x over 12, n over 12, 8 over 12. It's telling me to divide 12 n divided by 12. And then we have increase by 8, increase by 8. And then finally is 10. So that's easy. We know that equals 10. Increase means to add, right? So plus 8 equals 10. So let's write this more like an equation. We would have n over 12, and then we would have increase by 8 equals 10. Okay. Any questions? Ready for number 5? Okay, let's move on to number 5. All right, let's take a look here. -5 is the same as 3/4 of a number added to 7. Okay, so our first phrase is -5 is the same as. Then we have 3/4 of a number. What does the word of tell us to do? When we hear of, let's find it out over here. Where do we see of? Right there for multiplication. 3/4 of a number. Oh, look at that. It's almost identical. 3/4 times x. So this is telling us that we're going to multiply with that fraction with x, and then finally add it to 7. So what are we doing? We are saying -5 equals 3/4 times a number added to 7. Okay, so let's write that down. It's pretty much there, right? -5 equals 3/4 times n, with just no dot in between, plus 7, or another way to write this, I don't know about you, but I'm more comfortable with whatever it equals on the other side, on the right-hand side. So I'm going to write it that way. 3/4 times n plus 7 equals -5. Okay. So what I'm going to do is these three that we have, 5, 6, and 7, let's solve them. So I'm going to solve this one for practice. 3/4 n plus 7 equals -5. Okay, let's solve it. And we have a fractional coefficient. And we want to solve, get rid of it. Remember what our first step is? Find the denominator, multiply both sides by that number. In this case, it's 4. Because that will cancel. And we get 3n left, plus 7. Don't know why I put equals. Plus 7 equals -20. Okay. Let's get rid of the plus 7. So let's cancel that out. I got 3 times n equals negative 27. Let's divide away 3. And I get whatever negative 27 divided by 3 is. What is that? So that's my answer, negative 9. Okay. Now we saved the best for last. So this one's kind of different. So it says 3 times. So this is our first phrase, just 3 times. Then we have the sum of a number and 5. So my second phrase is the sum of a number and 5. And then my last phrase is the same as 27. Okay. All right. So let's take a look at this. This is different because this is saying 3 times. We're going to multiply 3, and that 3 is going to be multiplied to the sum of a number and 5. What does the word sum tell us to do? Add. Okay. The word sum is directing us to add. Well, the things we're going to add are a number and 5. A number and 5. And then we have is the same as 27. Okay. Okay. So 3 times the sum of a number and 5 is 27. This 3 has to be multiplied with all of n plus 5. How do we take care of that? What are we multiplying 3 with? N or 5 or both of them? Both of them. How do we do that though? Distributive property. So whenever we see something like this with the word sum, it's telling us to use the distributive property. We're going to write it this way. So this is 3 parentheses n plus 5 equals 27. Okay. So it's going to be the same on the second one where we have the word difference. Okay. Any questions? That one's a little tricky. All right. So this is the last one. So we start off with negative 4 is the same as, that's our first phrase. 7 times is our next phrase. And then the final phrase is the difference of a number and 12. And the word difference tells us to do what? Mathematically. Subtract. Tells us to subtract. They're kind of partners, sum and difference, sum and difference. Okay? So just like sum told us to add, this is telling us to subtract. Okay? So we have negative 14 is the same as 7 times the difference of a number and 12. And again, this is telling us to multiply 7 times both of these. So we need parentheses. Okay, so you might see 12 times the sum of a number and 8. 12 parentheses x plus 8. 6 times the difference of a number and 5. 6 parentheses x plus x minus 5. Okay, so let's write down what we have. We got negative 14 equals 7 parentheses n minus 12. We got to use the distributive property there. Or, again, I like the what it equals to on the other side, so I might write it this way. Okay. All right. So on today's assignment, we're going to take sentences, write them as equations, and then solve them. Okay? Let me pass out the assignment.